anything. So anyway, I just thought this was good, but what we're going to practice with today, just in general, like some operations with complex numbers, how to simplify radicals that have complex numbers, and ultimately the very last couple problems are actually going to be to use these to solve some quadratic equations, which is why we're talking about them in this unit. Okay, so in general, I don't know if you guys would have heard this term before, but all numbers can fall into the umbrella or the category of what we call complex numbers. And I'm going to show you how to write a real number like this. Not that I would ask you to do that, but I'll just show you. In general, they're in this format, a plus bi. So two terms, and it could be a plus sign in between them, or it could be a minus sign in between them. It just kind of depends on the question. So that does not have to be a plus. But where you see a position there, that would be the real part of the number, and where you see the letter I, that's going to be the imaginary part of the number. It is not a variable. I actually has a definition, which I'm going to give you underneath here in 1 second. But let me just go through this. So this says you can write a complex number in the form a plus bi. A and b would be real numbers. A is the real part. B times I is the imaginary part. Okay, now, if b is 0, the number a plus bi is a real number. So you can actually write just a normal, why do I not have my pen? Okay, you just write a normal number. So like, let's say I was trying to write the number 4. So I could write 4 as 4 plus 0i. And then 0 times I would just be 0. So you would see it written just as you normally do, the number 4. But I'm just saying you can write this in a complex format. And then this is kind of nitpicky. I'm not going to ask you this specifically, but this says if a is 0 and b is not 0, the number a plus bi is what they call a purely imaginary number. So let's say I had something of the format here like 0 plus, I don't know, let me just make something up, 3i. That could be, oh, that's freaky if that's what you were thinking. Okay, anyway, we could just simplify that to be 3i, so that would only have an imaginary part. So that's why they would call that a purely imaginary number, because it doesn't have a real part to it. Most of the questions you're going to see today are going to have two parts. They'll have an a plus bi, so two parts to them. Okay, now I was literally developed to take the square root of a negative, which you cannot do in your calculator, but we can do algebraically. So here's the definition. It says, they call this the imaginary unit, letter I, not a variable, is a complex number whose square is -1. So here's what this means. I squared is defined as being equal to -1. So that's a real number. I squared, you'll see this in some of the questions today, is just equal to -1. Okay, now the other part of that definition, if you take the square root of -1, that is equal to I. So there's two parts to that definition there, and that's actually how you can take the square root of a negative number, which is what we're going to work on here in a minute today. Let me give you that same thing with some numbers so you can kind of see how that's related. So if I did, let's see, like if I did 5 squared, right, that's 25, and then 5 is the square root of 25, right? That's kind of what the concept is that they're writing down there, where if I take the square root, this is 5. If you take the square root of -1, it's equal to I, whereas if I square I, that's equal to -1. So that's just the definition. Here's how this works in a problem. So if you can simplify normal radical, you can do this, I promise. It's just like one extra thing. I have negative square root 121. So in normal terms, I'd be like no real solution, which is true. But it does have an imaginary solution. 121 is a perfect square. Anybody know square root of 121? 11. Okay, so here's literally all you do. This would be simplified 11, and you just put an I with it. That's literally it. Now, if you do try to do this in your calculator, it's not going to tell you that. The concept behind that would be like -1 times 121, the square root of the -1 comes out as I, and the square root of 121 comes out as the 11, is the concept behind that. So basically, anytime you got a negative under a square root, you can just pull an I out in front and remove the negative. It's not considered simplified if you have a negative under the square root. Okay, now let's say we have something like I have here. This is negative 29. Okay, there's no factor tree you're going to make for 29. There's no perfect square that's going to go into 29. So this is not going to break down, but this is not considered simplified. So this could be considered negative 1 times 29. Negative 1 is a perfect square in imaginary land. So this comes out as I, and then you would just leave the 29 under the radical. You don't have to write that out. I'm just trying to show you where it comes from. So basically, if you just want to take an I out in front, you can take the negative out from underneath the radical, and then it's a situation where you can simplify it. Okay, let me have you look at this one. What would you tell me the square root of 36 is? 6. So what would you tell me that the square root of negative 36 is? 6i. Okay, you don't take a negative out. Sometimes people will do that on accident. That would literally just be a perfect square in imaginary land as 6i. Now, what would I do with the 3 that's already in front there? Multiply. And you could always multiply. They don't have to be like terms. Like this is a plain real number. It doesn't have an imaginary part. That's okay. You can multiply these. My answer to simplifying that question would be 18i. It's very similar to simplifying a radical. It's just going to have an I with it. Okay, now each one of these not perfect squares. So factor tree away if that's your jam. Or anybody know biggest perfect square that goes into 12? 4. So if this was me, here I usually just attach the negative to the perfect square when I do it. So I would real quick rewrite this as negative 4 times 3. It has to be multiplication. Negative 4 in imaginary land can be removed as 2i, no negative or anything with it, just 2i, and then keep the 3 under the square root. That would be simplest radical form, getting rid of that negative. Anybody know biggest perfect square goes into 108? A little bigger than 9.
36.
30, oh, very exciting. 36, yes. Okay, now actually, you know what? Let's say you just did let's say you did 9. What was the other factor with the 9? 12? Okay. Let's say I did that, right? And I broke this down a little bit. This would be 3i radical 12. I just have to recognize that the 12 I could break down a little farther. So that'd be 4 times 3. So then I could pull out the 2. So this would be 6i radical 3. So if you don't pick the biggest perfect square, that's okay. You might just have to break it down a couple times. If you pick the biggest perfect square, 36, it might just save you a little bit of time. But this would come out as 6i square root of 3 underneath. But just to show you, if you don't pick the biggest perfect square, that's okay. You just might have to break it down again. You'll just have to recognize if something under the square root is divisible by a perfect square to keep going. Okay. Anybody know biggest perfect square that goes into 54? No. Oh, you guys are on it today. All right, so I would rewrite that, negative 9 times 6. Pull that out, just a 3i, no negative with it. 2's already in front, just go ahead and multiply those together. So it'll be 6i and a 6 left under the radical. Anybody have a question? It's not terrible, I promise. Okay. Now, exciting news, we're going to add and subtract. All right, now, this, again, I promise it's not bad. If you are just adding two complex numbers together, I don't have anything in front of either set of these parentheses, and you don't have to rewrite this, but I'm just going to do it real quick. I can literally just drop the parentheses here. There is nothing that's going to affect changing any signs or anything like that. I'm just straight up adding these together. There's nothing to distribute, nothing like that. What you do to add these is combine like terms. So like the real parts, I've got a 3 and a 4. I just add those together like you normally would. That would be 7. And then I do the same thing with the imaginary parts. So I have 6i here, negative 8i. You're just going to combine like terms. So this would be 6 minus 8, so it would be negative 2i. And then it can't go any farther because I can't add real and imaginary numbers any further. That's that a plus bi form. If you are subtracting, okay, subtracting is tricky. I can just go ahead and drop the parentheses on that first complex number there. So I'm just going to write 9 plus 7i. The subtraction, though, because I have two parts, when I have this complex number, you have to subtract both parts. So that would turn into minus 2 and then minus 10i. So if you're subtracting, I would always tell you just take that one step, just make sure you distribute that subtraction to all the parts in that set of parentheses, because usually people will get the first part right but might mess up the second part because they don't distribute the negative. Once you're there, you're just going to take any real parts. Here I got 9, here I got negative 2. Put those guys together just like you normally would. This would be 7. And then I've got 7i minus 10i. So if I take 7 minus 10, that'd be negative 3, so I would just write that negative 3i. Is anybody having a question? Okay, the next two problems are actually kind of similar to what I just did, but they're going to kind of ask you to do a step first without really saying that. This first number here says 2 plus square root of negative 16. How could I rewrite the square root of negative 16? 4i. Okay, so this literally would just be 2 plus 4i. I'm just dropping the parentheses here. Okay, now the next number is 8 minus, so keep that right there, square root of negative 25. What would you rewrite negative 25 under the square root as? 5i. 5i. Okay. Now, this does not, some people were asking me about that. It doesn't change it to a plus. The square root of that negative 25 is 5i. There was subtraction between those, so don't change that. Once you're there, you're just going to take the real numbers. You got 2 and 8, so that's 10. And you've got 4 minus 5. So that would just be minus 1i or just minus I. Typically, if it's got a coefficient of 1, you won't see the 1 written in front of the number there. Okay, now I got one more. This first complex number, it doesn't look like it at this moment, but I'm just going to drop the parentheses there because there's nothing in front of that. What would you write for the square root of negative 1? Just I. So this would literally just mean, that's the definition, square root of negative 1 is equal to I. So that first complex number would be 6 minus I. Now, when I do this, I'm going to distribute this negative sign. So this would become negative 11. What would you tell me for square root of negative 64? 8i. Okay, now, this is a negative times a positive when I'm distributing the subtraction here, so this would be minus 8i. And then I would just combine my like terms. I've got a 6 and a negative 11, so negative 5. The real part goes first. Negative 1, negative 8 would be negative 9i. The imaginary part goes second when you set that up, and then that would be my answer. Just combining like terms. If you're doing subtraction, just make sure you distribute that subtraction to whatever the complex number is that you're subtracting. Is anybody having a question? I know this is so interesting and cool. Okay. Now, you can always multiply. The one thing I want to remind you here before we start doing any of these problems down at the bottom here, if you end up with I squared, which we will in a couple of these problems, I squared by definition is equal to negative 1. So in any of these questions, if we end up with I squared, I can actually replace that with a negative 1, which you're going to see here in a second. So 3i times 8i. Two purely imaginary numbers I'm going to multiply together. So if I do 3 times 8, I'm going to get 24. I times I becomes I squared. This doesn't look like it right at the moment, but the answer here is actually just going to be a real number because I'm going to end up I squared being equal to negative 1 really makes that 24 times negative 1. So then that's just my answer, is to go ahead and multiply those, negative 24. That's it. If you multiply two purely imaginary numbers together, the result is actually a real number. If I square negative 5i, remember that means I'm multiplying it by itself. Now, negative 5 times negative 5 would become positive 25. I times I becomes I squared, and then this is very similar to the question we were just looking at. 25 times I squared is really 25 times negative 1, because I squared is always equal to negative 1. That's the definition of it. So my answer to that question there would be negative 25. The last problem I have here is a little different. This is just actually a distributive property. You can always multiply. I'm going to distribute an I to both of the terms inside the parentheses there. just I times 11. Typically, you're going to write the number in front of the I, so I would write that as 11I. Now, I times negative 10I would be negative 10I squared. All right, now remember, I squared, by definition, just equal to negative 1. So really what I have here, I have 11I. This actually would become plus 10 because that negative 10 times that negative 1 would turn into a positive number. Now, I know this is kind of nitpicky. So the answer when I write this for this question, you're supposed to write the real part first in that A plus BI format. So I should see my answer here as 10 plus 11I. So I would just have to kind of reorder those terms real quick to write my answer. The real part coming first, the imaginary part coming second. Is anybody having a question? Exciting news, we are going to FOIL. Okay. Sorry, I secretly love this. Okay, not secretly, I'll openly tell you that. Okay, this works just like a normal FOIL. Okay, so first outside, inside, last, if you want to do that. If you want to do a box, I know some people are in love with the box. I love the box as well. So if you want to draw a box, draw yourself a box. So I just put one of the complex numbers down the side. So basically like each term, if you're doing a box, and the other one put across the top. So you could do it like that if you like the box. If you like a FOIL, you should get the same terms. I think of it as a double distributive property. I'm going to multiply both terms in that second set of parentheses by 3. So if I do that just like you normally would, 3 times 2 is going to give you 6. 3 times 4i. Just 3 times 4 is 12, and you put the I with it. And then I'm going to multiply both terms by negative 7i. So negative 7i times 2 is negative 14i. And just be careful here. Negative 7i times positive 4i gives you negative 28i squared. Whoops, sorry, I'm kind of going. And if you did the box, you would have gotten those same terms. Now, don't forget, I squared is equal to negative 1. What I might just do real quick as I go through here, you can combine these like terms in the middle. 12 minus 14 would be minus 2i there in the middle. And if you want to skip this step, it's fine. I'm just trying to write this out to show people where it comes from. That negative 28 times I squared is really going to be negative 28 times negative 1. So, oops, oh shoot, I just changed that to a plus for some unknown reason. Okay, this becomes plus 28 as that last term, that real, that becomes a real number. You can put the 28, that should have been a positive 6 there. So altogether 34, and then it should be minus 2i. It's a lot of work, and if you're comfortable with the I squared being negative 1 and doing that real quick and skipping that step, that's totally fine with me. Why don't you guys try to FOIL this one out? The next, or use a box if you like the box. The numbers are a little bit bigger than what I just was working with when you get your answer. Just remember, I squared becomes 1. Anybody feeling good about their, well, a couple people I know have the right answer. What'd you put?
Negative 59 plus 21i.
Yes, ma'am. Negative 59 plus 21i. Anybody not get that? Want me to go through it at all? I will be happy to. I love to FOIL. That sounded really creepy and weird, sorry. Okay, but totally true. All right, now, but real quick, I gotta show you one more thing and then we're gonna solve some equations. This looks really garbagey, right? Okay, because I'm seeing absolute values and like a graph and you know. Okay, it's not bad, I promise. So, and you guys will see this for sure again in trig. I've had people ask me questions about this in the resource room. So this will come back. You will see this again, I promise. So, absolute value of a complex number. So what's graphed over here, is the number 3 minus 2i. Okay, so in general, if you take the absolute value, you can follow this little formula. I literally stole this from the textbook, but it is the distance from that number to the origin in the complex plane. So I've got a picture with the complex plane just to show you how this works. I promise this is not bad at all. So what you guys are used to being the y-axis, they call that in the complex plane the imaginary axis. So up and down is going to be the imaginary part of your number. And then what you guys are used to seeing as an x and y, just in a normal coordinate plane, in the complex plane, the x-axis is what they call the real axis. So the real part of the number would go left or right. The imaginary part of the number would go up or down. So on a graph, this actual point would translate to be 3, -2 in the complex plane. That first number is positive, so it's +3. That second is -2i, so it would be a -2. So the actual point, they've got it graphed already for us here, but the actual point is here. So what they're doing, they're going over 3 and down 2. Okay, now the whole thing about doing an absolute value here, it's the distance from the number to 0 on the number line. For an imaginary number, it's the distance from the origin to that point in the complex plane. Okay, anybody seeing a right triangle there? Everybody should see a right triangle there, I hope. Okay, right triangle, like horizontal, vertical. I can't count boxes on a diagonal line. That's why I'm going to do this. So you can use this formula if you're bored, but maybe what I would just remind you of really quickly is, and this is the same thing. It is the same process, I promise. It's just a little more visual. If you have a right triangle, does anybody remember how to find the hypotenuse if you know the two legs? Yes, Pythagorean theorem, and then you were giving it to me. Okay, so not the A and B that is in this little form, like totally separate. All right, so Pythagorean theorem, and I'm only writing this because I'm trying to say that it's not what that formula is. Okay, so A squared, B squared, the two legs in the triangle equals C squared. So what they're doing here, one of the legs in the triangle is 3, so they're doing 3 squared. The other leg, now I know it's 2i, but if you're just talking about the length of that segment, that would be a length of 2. So 2 squared, that's your other leg. And then maybe I would call the hypotenuse C, just so it would match up with the Pythagorean theorem. But that's what's going on there. Take 3 squared, you get 9. 2 squared, you get 4. And add that together, you get 13. I would have to take a square root. Again, I'm talking about distance, so I'm not going to put the plus and minus symbol there, but that's why they have this right here at the bottom. That absolute value would be square root of 13. You should not have an I or a negative involved when you do these problems, so it should not be imaginary. Just square root of 13 would be the absolute value. Okay, so I have some unmarked, basically. This does say I and R for imaginary and real, but I'm going to show you guys how to graph these in the complex plane just real quick. So this is saying find the absolute value, but I want to actually graph the point. So before the absolute value it just says -7i, right? So if I wanted to write that as a complex number with both parts, it would look like 0 minus 7i. In the complex plane, if I'm going to graph that, I have 0 for my real part, which would be left or right, so we're not going to go left or right. And I would have -7 for my imaginary part. And I totally did not label these graphs, so I'm just going to go like 1, 2, 3, 4, 5, 6, 7. So that point in the complex plane, this on the imaginary axis here, would literally just be that point right there. That would be the point. Now, if I want to find the absolute value, I have to find the distance from that point to the origin in the complex plane. What would you tell me? Don't think too hard about this. What would you tell me the absolute value is here? 7. You can count this. This is just a straight vertical line, straight horizontal line. We can just count. That's not a problem. I don't have to use the Pythagorean theorem. This absolute value would literally just be 7. That would be the length of that segment. Okay, now the other ones are a little trickier because we have a real part and an imaginary part. So this says 10 plus 24i. So that would correspond to the point 10 for the real part, and then 24 for the imaginary part. Now, I do not expect you to sit there and write 10 and 24 different little hash marks. We're not doing that. Okay, so I'm just going to kind of eyeball this, and I'm going to say, okay, that's about 10, sure. And I'm going to come a little bit farther up here and say this is 24, just to give myself a reference. Because they're both positive, I would go right 10 and up 24 to get to the point. So that would be that point. If I want to do my absolute value, I'm just finding the distance from the origin to that point. There's a couple ways you could do this, but I'm just going to create a little bitty right triangle here. All right, and it should be easy. It should just go with the coordinates of the point. So I would go like over 10 up 24. So if I want to do my little Pythagorean theorem, my two legs, 10, 24, and we'd always be finding the hypotenuse here. So I might just write C so it looks like the Pythagorean theorem. When you guys do this question, I promise this is a nice number. It's a perfect square. But I would take the two legs, which are 10 and 24. Those will both get squared. And if you do this, you get 100 plus 576. And I know everyone knows this off the top of their head, but this is a perfect square. Anybody know what it is? It's 26, yes. If you take the square root of this, you get 26. And again, I know I just introduced that square root into a problem, right? But I don't put the plus and minus here because you cannot have a negative absolute value. It has to be a positive. Can't have a negative length of a segment. So that would be your absolute value there. All right, and I got one more. I'm just going to sketch this point. So this is -6 minus 4i. That would correspond to the point -6, -4 if we're graphing this. Now, again, you can just kind of eyeball, or I'm just going to go 1, 2, 3, 4, 5, 6, and then I'm going to go 1, 2, 3, 4. So I'm going to go 6 to the left and down 4. And that would be the point, would be kind of somewhere in the coordinate plane. And then I'm going to connect that back to the origin. So the absolute value is just the distance from that point to the origin in the complex plane. Now, when I do this, I know the coordinates were negative, but if I make myself a little right triangle here so I can just count the sides, distance can never be negative. So even though I'm going left 6 to get there, this distance would be +6. And even though I'm going down 4, the distance, if I'm talking about the triangle there, would be 4. And if you want, I'm just going to label the hypotenuse with a C like we did for the last one so it matches up with the Pythagorean theorem. So in any order, your two legs, 4 squared plus 6 squared equals my hypotenuse, which I labeled C squared. This guy'd give me, let's see, 16 and 36. And of course, you guys can use your calculator. This is 52 and not a perfect square. So I'm going to break this down a little bit, and you can't just a little bit. Anybody know biggest perfect square that goes into 52? It's only 4, right? So this is 4 times 13. And so I could pull a 2 out, but that's as simplified as I get. So this would be 2 radical 13. That would be your absolute value there. Is anybody having a question about how to plot the point or find the absolute value? You can, if you want to, use this little formula that they put in the directions, but I swear it's exactly the same thing as the Pythagorean theorem. You get the same answer. It's up to you if you want, or you can use Pythagorean theorem. That's my favorite, so that's why I did that. Okay, now here's the whole purpose of doing this. All right, last week and earlier this week, if we were solving this equation down here, any of these in the bottom, you would have been like, no real solution, which is true. But we do have solutions in imaginary land. So all I'm going to do is get x by itself. Each one of these we should be able to solve just using square roots. No factoring or anything here. So I'm going to subtract 25 from both sides. And then when I do that, to solve this, I get x squared equals -25. So I can take the square root, and now, because we know about I, we can actually simplify that. So when I introduce square root into the problem, okay, I introduced that. It was not already there. I do want to remember to put the plus and minus symbol because I do have two answers. And what would you write for square root of -25? 5i, done. Okay, so two answers, +5i and -5i. And if you wanted to, you guys could plug this back into the original problem and it should make it true using the properties we talked about for I today. Okay, if I'm doing this one, I'm going to divide both sides by 2. And perhaps I'm rolling my eyes a little bit because I know that's not a perfect square and I had to simplify it. Anybody know biggest perfect square that goes into 48? 16. Okay, so like I was telling you, you don't have to, but I usually attach the negative to the perfect square so I can just remove that as I go. So I would rewrite that real quick as negative 16 times 3. Now, if you like a factor tree, you can use a factor tree on this. Just don't forget to take an I out as you do any question that has a square root with a negative underneath. This guy would come out in front as 4i, radical 3, and then you just have the plus minus symbol with it because that is a situation where you introduce the square root into the problem to solve it. Okay, now no one foiled on this last one, right? Okay, we're going to get x by itself, so if it's in some parentheses, leave it there, all right? Do not distribute, divide. If you have an exponent on a set of parentheses, do not be distributing things into that. That will not be right. Just divide to get that away. You want to get the parentheses alone here. And that's going to leave you with x minus 5. That whole thing is squared. Don't FOIL, equals negative 20. Instead of a FOIL, what you want to do, we're just going to get rid of the parentheses by taking the square root. Square root and squared cancel each other out. Now, on this left side here, I would just be left with x minus 5. You can drop the parentheses. You still have that negative 5 with the x, though. Now, let me break this down real quick. So biggest perfect square that goes into 20 is really only 4. And so I would rewrite that real quick as negative 4 times 5. And, fired. I forgot my plus and minus symbol. Okay, and some of you did on your quiz, so don't forget that, okay? Now, this is going to come out as 2i, and then the 5 would be under the square root. The only other thing I need to do here, just really quickly, to get x totally alone, I would need to add 5 to the other side. Now, this is just my recommendation to you. If you're doing a question that looks kind of like this, I just write that number, the 5, immediately after the equal sign, and then the plus and minus, whatever I had simplified there. This would be 2i radical 5. There are 2 answers there. The plus and minus is just a shorthand way to take care of that, but I can't go any farther here because I've broken down that radical, and this has an imaginary part, and this 5 is just a plain number, so I can't do anything else there. Just similar to this last question, I can't do anything more, can't do anything more here. There's 2 answers there, but I can't go any farther than that to simplify anything. Okay, is anybody having a question? Okay, so the homework should be